right, this is Unit 4, Lesson 2, Graphing Rational Functions. Our essential question is, how can you graph a rational function? Here's our table of contents. Rewrite a rational function to identify asymptotes. So I want to rewrite g of x equals 4x divided by x minus 3 using long division. And then how is the quotient related to the reciprocal function f of x equals 1 over x? And then I want to sketch the graph. So first I'm going to write the equation, f of x over x minus 3. Then I'm going to use long division, okay? So I'm going to ask myself, x times what gives me 4x? In this case, 4. X times 4 gives me 4x. So that's 4 times x minus 3 gives me 4x minus 12, okay? And I'm going to subtract that. 4x minus 4x is 0. 0, because there is a placeholder right here in front of the in top of the 12. 0 minus negative 12 gives me a positive 12. So I have a remainder of 12. We can remember from the previous lesson that y equals a over x minus h plus k, where a is a stretch and compression, h is a horizontal translation, and k equals a vertical translation. All right, so we have g of x equals 4 plus 12 over x minus 3. So again, 12 was that remainder. That 4 out in front, that's what we divided, and we got as our quotient. So 4, that 4 out in front is my vertical translation. And you can rewrite this as 12 over x minus 3 plus 4. It's the same exact thing. 12 tells me it's a stretch or compression, and the minus 3 tells me it's a horizontal translation. So very similar to what we dealt with when we were talking about polynomial functions. So in this case, in the graph, the parent function f has been shifted up 4 units and then right 3 units. The resulting graph has been stretched vertically by a factor of 12. Okay. And of course, we've got vertical asymptotes at x minus 3. So this one up and down, that minus 3, which is the one that's underneath. Again, x minus 3 equals 0. So we get x equals 3. And then we have a horizontal asymptote at y equals 4. Rational functions. So just as a rational number is a number that is expressed as the ratio of two integers, a rational expression is an expression that can be expressed as the ratio of two polynomials, such as p of x over q of x, where the value of q of x does not equal 0. A rational function is any function defined by a rational expression, such as r of x equals p of x divided by q of x. The domain of r of x is all values of x for which q of x does not equal 0. So example, the function g of x equals 4x divided by x minus 3 is a rational function. Find asymptotes of a rational function. What are the vertical asymptotes for the graph of f of x equals 3x minus 2 divided by x squared plus 7x plus 12? Okay, so vertical asymptotes can occur at the x values where the function is undefined. Okay, so at this point, when I'm dealing with fractions, anything where my denominator equals 0 is going to give me an undefined function because I can't divide by 0. So I'm going to determine when the denominator of the rational function is equal to 0. So I set the denominator equal to 0. 7x squared plus 7x plus 12 equals 0. Okay, and then I'm going to factor this. So I have two factors, x plus 3 and then x plus 4. So again, when I'm factoring, I'm looking for a pair of numbers that multiply to get me my c value and add to get my b value. Okay, so in this case, 3 times 4 gives me 12. 3 plus 4 also gives me 7. I use the zero product property to set each of these factors to 0. So x plus 3 equals 0 and x plus 4 equals 0. Then I solve using the addition property of equality. So I get x equals negative 3 and x equals -4. So in this case, this function has two vertical asymptotes, one at x equals -3 and one at x equals -4. So I want to graph the function to determine if there are actually asymptotes at x equals -3 or x equals -4. Okay. And we can see that there are two vertical asymptotes, one at -3 and one at -4. Okay. So the graph is not defined at x equals -3 and x equals -4. These lines are vertical asymptotes. What about the horizontal asymptotes for the graph of f of x equals 3x minus 2 divided by x squared plus 7x plus 12? Okay. So to identify horizontal asymptotes, we have three cases that we need to look at. So case number one is when the degree of the numerator is less than the degree of the denominator. Okay. So what that means is I have x plus 4 on top, x squared minus 3 on the bottom. My leading coefficient in the top has a degree of 1. Okay. My leading coefficient in the bottom has a degree of 2. So 1 is less than 2. As the value of x increases, the value of the denominator gets very large in relation to the numerator. The value of the function gets closer and closer to 0. So basically what this means is if I have a degree that is smaller on top, larger on the bottom, I will have a horizontal asymptote at y equals 0. Case number 2 is the opposite, when the numerator has a greater degree than the denominator. Okay. In this case, as the value of y increases, the value of the numerator gets very large in relation to the denominator. The value of the function continues to increase. Okay. So when the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. And then our last case, case 3, is when the degree of the numerator and the denominator are the same. So in this case, I have 2x squared and x squared. Okay. I can use long division to rewrite this. So I get 2 plus x plus 3 divided by x squared minus 1. Again, that 2, that's my vertical side, whether I'm going up or down. So that's going to tell me where my horizontal asymptote actually is. Okay. The other way to think about it is you're looking at the ratio of the leading coefficients. So in this case, I have 2x squared and x squared. Those are my leading terms. Okay. So I'm going to take that ratio of 2 over 1, which is just 2. So if I'm looking at this, I have 3x and x squared. So my numerator is smaller than my denominator. So that means I'm following case 1. So that means there's a horizontal asymptote at y equals 0. Graph a function of the form ax plus b over cx plus d. What is the graph of the function f of x equals 2x plus 1 divided by 3x minus 4? Okay. First, I want to determine if there is a vertical asymptote. So I set the denominator equal to 0. 3x minus 4 equals 0. 3x equals 4. So x equals 4 thirds. So there's my vertical asymptote. I can then look at this. I have 2x and 3x. So for my horizontal asymptote, they're the same. So that means I'm looking at the ratio of my leading coefficients. So I'm going to get a ratio of 2 over 3. So that's my horizontal asymptote, y equals 2 thirds. Then I can graph the function. First, I'm going to indicate the asymptotes. Okay. Then I'm going to choose the x values on either side of the vertical asymptotes and evaluate the function for those x values to create coordinate points. So you can use a table of points if you would like to graph this. And I'm just going to plot the points and connect the dots. Okay. You can also use Desmos or graphing technology to help you do this as well. Use a rational function model. The cost of removing a pollutant is modeled by the given function where f of p is the cost in millions of dollars of removing p% of the pollutant. What percent of the pollutant can be removed for $78.3 million? Okay. So my function in this case is f of p equals 8.7 p divided by 100 minus p. So in order to solve this and graph this, I'm going to actually do a couple different things. I'm going to figure out what my vertical asymptote and my horizontal asymptote are. In this case, my vertical asymptote is 100 minus p equals 0, or p equals 100. And my horizontal asymptote is, they have the same degree. So it's just the ratio of the leading coefficients. So 8.7p divided by negative 1p. So 8.7 divided by negative 1, or negative 8.7. Okay. Then I'm going to graph the vertical and horizontal asymptotes. And we're going to look for a percentage that is positive, because you can't have a negative percentage in this case. So we're going to restrict the domain to 0, between 0 and 100. And then I'm also going to graph the line y equals 78.3, because I'm looking at where the terms intersect. Determine where the graph and line intersect. So if I'm looking at this graph, I've got my vertical and horizontal asymptotes. Okay, and I've graphed my equation. And I've also graphed the line y equals 78.3. I can see that they intersect right here at this 90, 78.3. Remember that our x value in this case represents p, which is our percentage. So the graph and the line intersect at 90, 78.3. This means that 90% of the pollutant can be removed for $78.3 million. Graph a rational function. So what is the graph of f of x equals 4x squared minus 9 divided by x squared plus 2x minus 15? Okay. Again, I'm going to determine if there is a vertical asymptote by setting my denominator equal to 0. Okay, in this case, I'm going to factor. I get two factors, x plus 5 and x minus 3. So I have vertical asymptotes at x equals negative 5 and x equals 3. Then I'm going to see if I have a horizontal asymptote. So I'm going to look at my leading coefficients and degrees. So they both have an x squared. So they're the same, which means I'm going to look at the ratio. So in this case, I have a ratio of 4/1, or 4. So I have a horizontal asymptote at y equals 4. Then I'm going to sketch the graph. I substitute values in for x and solve to determine points. You can also notice that this line over here does dip actually below the asymptote, the horizontal asymptote. Okay. And then it's going to go back up towards that asymptote. Okay, so for x is greater than 3, as the x values get larger, this graph drops below the horizontal asymptote and then approaches it from below. Summary. So throughout this lesson, we talked about vertical and horizontal asymptotes in particular. For vertical asymptotes, you want to set the denominator equal to 0 and solve. For horizontal asymptotes, you've got three different cases. For the first case is when your numerator is smaller than your denominator. You'll have a horizontal asymptote at y equals 0. Case 2 is when your degree of your numerator is greater than the degree of your denominator. You have no horizontal asymptotes. And where the same, you're looking for the ratio of the leading coefficients. And that is the end of Unit 4, Lesson 2.